our channel. In this video, we are going to discuss exercise 3.4. And the problems under this exercise, we have to use both the substitution method and elimination method to get the values of the variables. Okay, but here I am mainly using only the elimination method because we are very much clear about how the problems can be solved using substitution method. Okay, let us move to the second method. It's very important, and usually we are using this method to get the values of the variables in the given pair. Understood? Okay, let us move to the first question. That is 2x plus y is equal to 5. 2x minus 3y is equal to 4. Elimination. Elimination means we are eliminating one of the variable and we will have an expression with one variable. The substitution method, we expressed the given equation, one of the given equation with respect to one variable, isn't it? But here what we are going to do, we are eliminating one of the variable first without substitution. Okay, both are different methods. Understood? So how this elimination method can be applied in the first question? So 2x, here we have x. The coefficient of x here is 1, here that is 2. Okay, the eliminating means we should get that coefficient of any one of the variable as the same coefficient. Okay, in order to make the coefficient of x in the first equation same as the coefficient of x in the second equation, what can be done? See children, here the coefficient of x is 1, isn't it? X means the coefficient is 1. Okay, you can easily make this 1 in the form of 2. How? Because you can multiply throughout the equation with the 2, automatically the coefficient of x in the first equation will be 2. Okay, this is very important children. In order to make the coefficient of x equal to the same as the coefficient of x in the same variable, this is the method. But here very important point, only when the coefficient of x is 1. Then only you can easily make the coefficient of x is equal to the same as the coefficient of x in the second equation. Understood? As the problems comes, I will explain. Okay, how the other pair of linear equations, how that problems can be solved easily. Okay, but here being the coefficient of x in the first equation is 1, we are going to multiply equation 1 with the coefficient of x in the second equation, and we are making any change for the second equation. Okay, so I am marking here the first equation, this x plus y is equal to 5 as equation number 1, and this can be equation number 2. So what is the step I said? That is equation 1 must be multiplied with 2 in order to make that coefficient of x in the first equation same to that of the second equation. Okay, so multiply means you have to multiply both the terms in LHS as well as the RHS. Okay, that is the rule. Okay, so 2 into x plus y, that is 2x plus 2y, understood, equal to 10. 5 2s are 10. And we are making any change for the second equation, that is 2x minus 3y is equal to 4. So this is equation number 3 and this is equation number 2. We are making any change for the second equation, and from the first equation multiply with 2 we got the third equation. Now next comes very important step. How can we eliminate that x term, that is 2x, 2x. We have now the coefficient of x having the same both the first two equations. Okay, and how can we eliminate? What can be done? That we can eliminate only this x term, that is 2x, only when we are subtracting 2x minus 2x. That is 0, that term get eliminated, that is x term is not there. If you are subtracting equation 3, this is the indication, minus 2. Okay, 3 minus 2 means the second equation must be subtracted from the third equation. How the subtraction process is going on? How can we subtract two equations? Subtract LHS part and RHS part separately. That is the usual procedure. Okay. So in order to subtract, we have to change the sign. Then we are adding. It is clear, children? So I am going to change the sign of the second. The second in the sense the equation which I wrote secondly. Okay, so I am going to make the change, sign changing. Okay, minus sign become plus and minus. Understood? Okay, now we can add. Add means get cancelled. Okay, so 2y here now become plus 3y. So 5y is equal to, the new sign is minus 4, the constant in RHS. So 10 minus 4 is 6. Okay, implies y is equal to, see children, 6 by 5. 6 by 5. Okay, so this is the value of y. So what is the next step? We should get the value of x also. Okay, we first of all we eliminated, but we need the values of x and y. That is solving. Okay, so in order to get the value of x, you can substitute any one of these equations. So I am going to substitute this value of y in equation number 1. Okay, so therefore 1 becomes, okay, in order to get the value of x, so x from 1, x is equal to 5 minus y, isn't it? Plus y become minus y. So 5 minus, okay, y is 6 by 5. I just substituted the value of y as 6 by 5, that we got already. So 25, 5 5s are 25, cross multiplication. Okay, 5 5s are 25 minus 6, then it becomes whole divided by 5. Cross multiplication. Okay, if we have a natural number, you can make this as 1. Understood? So 5 5s are 25 and 1 6 are 6. Okay, so 25 minus 6 is 19 divided by 5. So what are the values of x and y? So x comma y in ordered pair we can write. So we have now the value of x as 19 by 5 and for y 6 by 5. Okay, this is entirely different from the substitution method. Okay, so the question is, in the question we have to find out the answer, that values of x and y, both elimination method and substitution method. I think the substitution method now it is very clear to you. Now you can follow this elimination method to get the answer. Okay, this is all about the first question. Now we are moving to the second question. Now we are solving the second question. This is also very simple. Okay, see here, 3x plus 4y is equal to 10 and 2x minus 2y is equal to 2. This is very important point I have to explain to you children. See, after getting an equation, you just go through the terms. And if you can simplify, you just simplify. Okay, I will explain with this example. That is 3x plus 4y equal to 10. There is no common terms. Okay, so we can't do anything with respect to the first equation. Okay, but in the second equation, 2x minus 2y is equal to 2. You just read out the question, the terms. So you will get that idea what can be done for each equations. Okay, so in 2x minus 2y is equal to 2. 2 is common. So you can divide throughout this equation 2 with the 2. Okay, so you can simplify. That means you can simplify the second equation. Okay, so I can marking this as first and the second as this one. Okay, and I am going to first of all I am dividing this equation 2 with the common factor 2. Okay, so equation 2 get divided with 2, the number 2. Okay, so it becomes 2x by 2, 2 get cancelled, x and here 2y by 2, y. Okay, here it becomes 2 by 2, constant also, RHS also divided. Okay, what we are doing in LHS, the same you have to do in the RHS also. So this is the equation number 3. Okay, that is this equation 2 now reduced in the form x minus y is equal to 1. Now we have the first equation, that is 3x plus 4y is equal to 10. This can be equation number 1. We are making any change for equation number 1. See, now it is reduced into the first equation. See children, here the coefficient of x, either x or y, if it comes unity 1, you can multiply with that same as the coefficient of x in the second equation. Okay, here that is the way you can make the coefficient of x. So both the equations the same. So see children, in elimination method, this is the very important thing. We have to definitely make the coefficient of either x or y the same by multiplying with a suitable number. I disclaimed that in the next step, either by adding or subtracting, you can easily eliminate one of the variable. Hope this idea is clear, children. So in order to do that, okay, I am multiplying this. How this equation of x, that the coefficient of x of first equation can be made equal by multiplying with the 3. See, if you are multiplying with the 3, this becomes 3x, 3y equal to 3. Okay, so this equation 3 should multiply with the 3. That here, where we get this 3? 3 is the coefficient of x in the first, I mean this equation. Okay, that is 3 should be with the 3. We have to multiply equation this 3. Okay, don't confuse with that number 3. Okay, so it becomes, okay, so this equation should multiply with the 3. So 3x minus 3y is equal to 1 into 3. 3 RHS also multiply. So you have this equation number 4. Okay, now see children, both equations having the same coefficient of x, that is 3 we got. So how this term can be get eliminated? By subtracting. Okay, same coefficient with the same sign gets eliminated only when we are doing subtraction. Okay, subtraction means that is now we are subtracting 1 minus 4 from equation 1. So the second, the equation which we wrote secondly, we have to change the sign. That means we have now minus 3x minus 3y become plus 3y and here become minus. So in the next step, see children, 3x and minus 3x get cancelled. 3y and 4y both are positive, add. Okay, add and give the variable. Okay, and 10 minus 3 is 7. Okay, implies y is equal to 7 by 7. That is we have now the value of y as 1. Then how we get to the value of x? By substituting one of the equation. I think it would be better to substitute in the third equation. Okay, so we are substituting from 3, any one of the equations, that doesn't matter. From 3, okay, here children x will be 1 plus y, minus y become plus y. So 1 plus 1, the value of y here 2. So we have now x comma y as 2 and y for 1. These are the values of x and y. Now the third sub question. Okay, this is another very important problem. Okay, let us see children. So 3x minus 5y minus 4 equal to 0. And in the second equation, 9x is equal to 2y plus 7. Okay, see children, here this constant term is in the LHS. But here not only the constant term, the second equation, both the y term, the variable y term as well as the constant term is in the RHS. Okay, so children, in order to apply this elimination methods, very important point. See, it would be always better to keep the constant alone in RHS. Okay, and all other terms must be taken to LHS. That is the way to follow when we are doing the elimination method. That point is clear, children. So children, in the first equation, here we have the constant in minus 4 is in LHS. So in the first step, we have to take this into the RHS. The same way in the second equation, we can take only the variable term 2y to LHS. So 2y, positive 2y become minus 2y in the LHS. And we are keeping 7 in RHS itself without any sign changing. That is the first step, and we can represent those equations as equation number 1 and 2. Okay. So here we are getting 3x minus 5y. When this minus 4 becomes positive 4, at 9x minus 2y. Okay. And 7 is there. So I am marking this as equation number 1 and equation number 2. See children, here we have look into the first variable and its coefficient. Okay, I already told you just to read out the terms. Okay, so that you can get the idea how that next step can be started. So 3x and 9x. Since here the 9 is a multiple of 3, you can easily make the coefficient of x in the first equation the same as the coefficient of x in the second equation. That is 9. How 3 can be make into 9? Multiply with the 3. So that means you have to multiply throughout the equation with the number 3. Okay, so through not only for the x term, so that is the first step. Okay, here anyhow 5 you can also eliminate first that a variable y, but here this 2 and 5. Okay, 5 is not a multiple of y. If we have multiple of y, here that is coefficient of y as a multiple of 2, you can do that for y also. The same procedure you can do for y also. But here we can't do since 5 and 2. Okay, 5 is not the multiple of 2. So, but here you can do since 9 is a multiple of 3. So, I am going to multiply equation 1 with 3 in order to make the same as the coefficient of x in the second equation. So, 9x, okay, minus 3 into 5, 15y, and 3 4s are 12. This can be new equation, that is equation number 3. And I am making any change for equation number 2. That is here 9x minus 2y is equal to 7. And as usual, how this x term get eliminated? By subtracting equation 3 from equation 2. So we have to put sign changing, that is here minus 9 minus 15y plus and for 12 negative. Then this term get cancelled. Okay, so we are solving in this manner, that is 2 minus 3. After changing you can add. Now we have minus 2y plus 15y. Okay, 2 minus. Okay, sign is minus. So take the difference and give the sign of 15, that is 13y, positive 13. Okay, because y positive 15. And here what comes? 7 minus 12, difference, and it give the sign of this 12, that is 5 minus 5. Okay, implies y is equal to minus 5 by 7. So this is the sorry, not 7. Okay, 5 by 13. This 13 will be there. Okay, so this is the value of y. So in order to get the value of x, what is the condition? You can substitute this value of y in one of the equation. Okay, so I am going to substitute in equation number 1. That doesn't matter, any equation. So from what you are doing, and you have to mention here. Okay, from 1, you can write this equation 1 with respect to x term, that is 3x equal to 4, and this minus 5y plus 5y. Now I am going to substitute the value of y as negative 5 by 13. 5 is already there, 5 into minus 5 by 13. Okay, so here you will get 4 plus here, but 5 5s are negative 25 divided by 13. So as usual, you can do the cross multiplication. Okay, so you will get 4 into 13. Okay, that is 52 minus 25 divided by 1 into 13, 13. Okay, so what we have now? We have 3x. We have 3x in LHS, that can be equated to 52 minus 25. By subtraction, you will be getting, that will be, we can subtract this 25 from 52, isn't it? Okay, so you will have 7 and 27. So 27 divided by 13 is 3x. But what we need, children? We need x. So that you have to take this 3 to denominator in the RHS. So x will be 27 divided by 13, and 3 will be here under multiplication in the denominator. That is the way that 3 will join with the 13. Okay, so see children, 3 and 27 multiple of 3 is 27, that can be easily get cancelled, reduced. So 9, 9 3s are 27. So now we have the value of x as 9 divided by 13. So what are the values of x in the given problem? That is x comma y is equal to 9 by 13 4x and minus 5 by 13 4y. So these are the values of x and y. Okay. Now we are moving to the fourth question. It's very another important. All the questions are different children. Okay, now how this fourth question can be simplified and we can apply a substitute elimination method. Okay, so children, x by 2 plus 2y by 3 equal to minus 1. Here x minus y by 3 equal to 3. Here children, constants are there in the RHS, but the problem is here we have to cross multiply and we can eliminate the denominator first. We have eliminated in the sense we can take this denominators, that is the given equation, free from the denominators. I cross multiply with the coefficient of x is 1, 1 3s are 3x, okay, plus 2 2s are 4y and divided by 2 in, we are just doing the cross multiplication, okay. So 2 3s are 6. This is equal to negative 1. Okay, now we got an equivalent expression of this given equation, now reduced into this form. Okay, so in the next step, what is our aim? We have to remove that denominator. Okay, it should be of the standard form of pair of linear equations in two variables. That is our aim. For that, this 6 should be taken to RHS. So division become multiplication. Okay, in the next step, so the 6 into minus 1 is minus 6 and no change in the numerator. I am going to multiply this negative 1 with the 6, that is negative 6. How this equation 1 reduced in the form of general form of or the standard form of pair of linear equation two variables, clear children? This is the way you can remove this denominator. Okay, you can't simply write x plus 2y is equal to 1. We can't do. We should get an equivalent expression. This is the only method by cross multiplication. The same way children, here how this can be. Here also you can see 3 as the denominator. The coefficient of y is 1 by 3. Okay, in order to remove or in order to that equation, the pair of linear equation, the general form of pair, you have to cross multiply. That means 1 is the coefficient of x, 1 3s are 3x and cross multiply. Okay, 1 into 1, here the coefficient of y is 1. So minus y itself whole divided by, okay, 1 3s are 3 equal to 3. Okay. Okay, this 3 is for both the terms in the numerator. Now we have to take this 3 to RHS under multiplication. So it becomes 3 3s are 9. Okay, so we can have two equations and that is in the form of general form of pair of linear equations in two variables. Now see children, after doing this, okay, what happened? Here 3x and 3x. We have already that one of the variable, that is x and its coefficient is the same, 3 and 3x. Okay, in this type of problem, you can easily eliminate this x term, just subtracting. Okay, so I am going to mark this as equation number 1 and this as equation number 2. Okay, so without doing in this manner, multiply with the 3, because we need not make that the coefficient of x the same, because it's already the coefficient of x are the same. So children, so in order to apply the elimination method, see, if any pair having the same coefficient for either x or y, you just subtract. Okay, same coefficient with the same sign, just subtract so that you can easily eliminate that variable term. Okay, so that is what I am going to do here. That is equation 1 minus 2. So we have to change the sign of the second equation. So minus, this minus y become plus and here minus. Okay, so the next step, this 3x and minus 3x get cancelled. So here 4y, and here the coefficient of y is 1. 4 plus 1 is 5y is equal to negative 6, negative 9 is negative, add and give negative sign. So negative 15. So from here you will get y is equal to negative 15 by 5, that is 3, negative 3. Okay, so we have to substitute this value of y either in equation 1 or equation 2. So it would be better to substitute in equation 1. Okay, so from 1 we have to express that in terms of x term. So 3x will be minus 6 is already there in the RHS, and plus 4y become minus 4y. So I am going to substitute here. 4y means 4 into y, 4 into minus 3. That is 4 minus 6 minus and minus 3 plus 5 plus 12. So minus 6 plus 12. Take the difference. Okay, that is positive 6. This is 3x children, but we need x alone. So x by this 3, that is 2. Okay, so the values of x comma y for this problem, that is the fourth sub question, and that is 2 and minus 3 for y. So this is all about the first question, that is we have 4 sub questions and we have done. Okay, and next comes the word problems that we will see in the next video. So thank you children, thank you for watching and supporting my channel. Thank you.